Now, I mentioned earlier PGP, and I'll make this my closing slide. The professor from my first MIT calculus class was George Thomas. He was a hero of mine. He wrote my high school calculus textbook. I loved that textbook. It was different than all my other textbooks. I didn't know why. It was just different in a good way. I really learned calculus well thanks to that textbook. After that first class, I went up to Professor Thomas to gush, tell him how great his book was. And I asked him, I said, your book is different. Why? He said, do you know what you did differently to make it so great? He looked at me, he smiled. He said, come to lunch, I'll tell you. Over the course of many lunches, Professor Thomas told me about PGP, his concept of how children learn math, or anything else for that matter. When anyone works on a problem they haven't seen before, they start somewhere, probably in the wrong place. A mistake maybe, a good one. And they try things, and they fail, and they try some more things, and they fail some more. And eventually, they figure it out. Maybe it's a formula, a tricky word problem, whatever. That's the first P, a particular case, they figured it out. But deep learning and invention comes from coming up with general principles or formula that can be used on similar problems. You want to generalize it. That's the G, generalization. That's taking the specific problem with specific numbers and units and whatever, and generalizing it with parameters, variables, or anything else one needs to generalize. Now we've got a formula, an algorithm, or some kind of procedure to follow to solve similar problems with different numbers, different parameters. The second P in the PGP, the third letter P, is also particular, but this time we solve a particular problem using our generalized formula or algorithm. Does it work? Let's try some new particulars. Does it account for edge cases? When we're on the lookout for mistakes, actively seeking them, actively seeking mistakes because we want to know if our formula is good. We've got our priorities straight. Cases the formula doesn't handle but could. Maybe it's not general enough. Let's revise the formula and retest it with more particular cases. The beauty of PGP is that it takes the pressure off the learner. It encourages the student to look for errors. The student is actually excited to find errors. And when no more can be found, the endorphin release is tremendous. It makes students want to go through the process again and again. Students actually seek out tough problems to get that endorphin release. Students who use these techniques are exposed to it, or parents who train them this way. They also become good at estimating how easy or tough a problem is. That's a great skill to have.